Hi everyone. Okay, so we are talking about fronts, and this is straight out of our textbook here. And we looked at oil and water today in class, if you'll remember. Um, and we talked about how oil and water don't mix, and that's sort of like fronts that we're studying here. So a front is the boundary where unlike air masses meet, but they don't mix, so they collide basically. And it's really interesting to think that there are blobs of air out there above the ground that are constantly moving around because of the winds of the Earth due to Earth's rotation and the thermal energy on the Earth. We'll talk more about that soon. But these air masses, there are different types, as we're going to discuss. These air masses move around and bump into each other, and they affect the weather in certain areas of the Earth, including our place here in the southeast of the United States, but they also affect the climate of a region and the climate of the whole Earth. It's kind of cool. So fronts are where these air masses collide. Storms and weather changes typically are results of these air masses colliding. So, the ancient Greeks thought it was Zeus throwing lightning bolts, but it turns out it was air masses because of their thermal energy, temperature, and humidity that are bumping into each other. So we talked about in class the four types of fronts. So we have cold fronts here, and typically cold fronts form when a cold air mass and a warm air mass collide. And because the cold air is denser than warm air, the warm air is pushed up, and it causes things like bad thunderstorms and tornadoes and heavy winds and rain and all sorts of severe weather situations. So that's cold fronts. We have warm fronts when a fast-moving warm air mass overtakes a slower cold air mass. So cold air typically will sink because it's more dense. Warm air kind of comes in, overtakes the cold air, and you get things like snow or that kind of thing at the leading edge of this front. But typically they move slow, and you might get rain clouds, but they're associated with warmer and kind of more humid days. So that's a warm front. We see a lot of those here in South Carolina. Occluded fronts. Now, we're going to talk about this more in class tomorrow. This is a fun word, occluded. I'll read from the textbook here. Sometimes a warm air mass gets caught between two cold air masses, forming an occluded front. So warm air mass caught between two cold fronts forms an occluded front. Because the cooler air is denser, so it's going to sink down, it moves under the warm air, causing the warm air on both sides to rise. And when the two cold air masses meet, they mix together. So air temperature drops as warm air mass becomes occluded or prevented from reaching the ground. So an occlusion is something that prevents something from reaching a certain spot. In medical terms, we use the word occlusion a great deal. It's a very good SAT word, so occlusion. So the warm air is prevented from reaching the ground. And as the warm air mass rises and cools, clouds gather, and you get things like rain and snow. So this is typically in the southeast how we get rain, cold rain, and sometimes even snow. Here in Sumter, in the Sumter area, in the high hills of Santee, you have a warm front that gets wedged between two cold fronts or two cool fronts, and that warm front gets sort of pushed up, or the warm air gets pushed up, warm air mass, and that forms an occluded front. So it's kind of cool. And then last, we have stationary fronts, and we see a lot of these too in the southeast of the United States. So sometimes a cold air mass and a warm air mass meet, and they can't really move each other. So they kind of collide, but they can't budge. They can't go either way. So this non-moving front is called a stationary front. And we see this a lot in the southeast of the United States, where two large air masses, maybe cold, or warm and warm, or cold and warm, they don't really budge. But you have storms along the front. So that's here where, especially in the spring, we kind of get this warm and cool air meet. We get a lot of condensation from this, so we get rain, snow, fog, clouds. Anytime we have a very cloudy day, a lot of fog, a lot of times it's because of a stationary front where two air masses are wedged in this epic battle between the two air masses. So a stationary front may bring many days of clouds and precipitation. Not always, but anytime you have a cloudy 3, 4, 5 days, that's typically because a stationary front. So it's kind of cool. So tomorrow we're going to talk about our next guiding question. But my question to you tonight is, what do all of these different types of fronts have in common? So think about that. We're going to look at these. Here's some images. So cold front, warm front, occluded front. You see the cold air here and the warm air gets pushed up. And a stationary front where the air masses can't move. Um, so anyway, let me know if you have any questions, and I hope that helps with our studies of air masses and fronts and weather in the atmosphere.